Most of us, at some stage in our lives, have jumped off some elevated height, like a table or a roof, or maybe even a cliff. If we fall, we gain speed due to the acceleration by gravity. We saw in the Defining Gravity video that the higher an object is dropped, the greater its speed when it hits the ground. In the kinetic energy video within this chapter, we define kinetic energy to be proportional to the square of velocity. In other words, an object's kinetic energy increases as velocity increases. This leads us to conclude that objects dropped from a high distance will have more kinetic energy when it hits the ground compared to objects of the same mass but dropped from a lower distance. So where does this energy come from? The energy possessed by objects in a gravitational field is called gravitational potential energy. This energy comes from the fact that all objects under the influence of gravity will want to move to the lowest level due to gravity's acceleration downwards. So in order for an object to be raised above its lowest level, work must be done to lift it up. Recall our weightlifter Ryan Kennelly, who holds a world record for the bench press. In order for the weights to be lifted above his chest, he had to work against gravity by applying an upward force. This work is equal to the force of gravity, which is mg, multiplied by the distance that the force was applied, which is displacement height h. So the weights had work done on it, and in the process has gained energy equal to the work done. This energy is stored in the weights as gravitational potential energy, which is given the symbol delta U. It is called potential energy because it is not yet used while the weights are held above Ryan's chest, but it has the ability to do work. If he suddenly lets the weights go, it would drop down and start to accelerate, and in the process increase its velocity, thereby increasing its kinetic energy. This kinetic energy comes from the stored gravitational potential energy. Let's now have a look at some of the properties of gravitational potential energy. From its definition, gravitational potential energy is proportional to the height, or vertical displacement. The higher the object is lifted from its lowest point, the more gravitational potential energy it acquires. So an apple, being raised by some height h, will have gravitational potential energy given by mgh. The same apple raised to twice the height will have twice the gravitational potential energy. Gravitational potential energy is a relative quantity and depends on where the lowest point of displacement is for the mass. For example, if you displace an apple a distance h above a table, its gravitational potential energy is mgh. If you displace the same apple by the same height, but this time above the floor, it will have the same gravitational potential energy even though it is lower compared to the first apple relative to the ground. The point is that both apples were displaced by the same amount relative to their origins, so therefore will have the same gravitational potential energy. But if the first apple is now dropped such that it now lands on the floor instead of the table, then its gravitational potential energy is determined relative to the floor instead of the tabletop. It will have more gravitational potential energy than apple 2 because the vertical displacement is now greater. In most applications of gravitational potential energy, it is common practice to define the height relative to the Earth's surface, so the potential energy at the Earth's surface is zero. Because gravity only acts in the vertical direction, gravity does no work in moving an object horizontally. Therefore, there is no horizontal gravitational potential energy acquired when an object is moved in a horizontal direction. To illustrate this, consider the following stairwell, which leads to a vertical drop-off. One can ascend to the top of the stairwell in one of two ways. Firstly, by taking path A and climbing directly up the vertical side, or by taking path B and walking up the steps. Which path has the shortest route? It is obvious from the diagram that path A is the shortest route, taking the shortest distance to get to the top. But because both paths end up at the same vertical height, then the gravitational potential energy gained via path A is the same as the gravitational potential energy gained by taking path B. And here's the proof. Once you get to the top of the stairwell, you can step off the edge and gravity will start to work on you and convert your potential energy into kinetic energy as you start to fall down. This work is equal to the force due to gravity times the displacement. Since gravity acts directly downwards, then the displacement is the height of the stairwell. So the work done by gravity is dependent on the height only and does not depend on the path it took to get to that height. So you gain no gravitational potential energy by having horizontal displacement. Now to test your understanding. Consider the following scenario where you have two identical penguins of the same mass sliding from the top of an icy hill down to the ocean. They take different paths to get down, but both paths have the same length and start at the same height. The first question is, which penguin is traveling faster at the bottom when it hits the water? Second question is, which penguin will get to the bottom first? In summary, gravitational potential energy is defined as the work done against gravity to raise a mass m to a vertical displacement h, and is given by the formula delta U being equal to mgh. Gravitational potential energy has the same unit as work and energy, that is, the joule.